Okay, this is free response question number 2, and I'm gonna just say in advance that some of it is just really ridiculous and I think completely unfair in 15 minutes, but I'll go through the solution, and when you see a problem like this, you'll choose what to do. All right, so we're talking about in the time interval from 0 to 4.5, water is going into a tank at a rate of blah, blah, blah. But A of t is the water going in. That's what we care about. Okay, at the same time, B of t is a different tank. That's tank B. And that one, water is also going in. Okay, so we have 2 tanks that water is going in. Both tanks are empty at time t equals 0. So that means at t equals 0, the water is 0. They give you 2 graphs, one of A of t and one of B of t. And first of all, you have a calculator. So if you don't know which function, then you can put A of t into your calculator, see what it looks like, and oh, actually, they tell you. I'm so stupid. Okay, it says A of t is the top one, B of t is the bottom one. Okay, and they're telling you where they intersect. So there's 2 points of intersection. So one they gave you, which was 2.416, and the other one is K. And right away you should know they're probably going to be asking for K at some point, but let's just start with part A. How much water will be in tank A at time 4 at t equals 4.5? So that's all the water that went in from 0 to 4.5 of A of t dt. Now, what are we going to add to that? How much did it have at t equals 0? It didn't have anything, so you don't need to add anything actually to it. So that's good news. You're going to use your calculator, and you have the function A of t, so your calculator will do all the work, and you should get 66.5321. Now, they were pretty generous on this with the points, so if you set up the integral, that was worth 1 point, and if you got the answer, that was worth 1 point. And I think they were that generous because part B is quite cuckoo. Okay, here's part B. So it's saying that from the time 0 to K, so we don't know what K is. Oh, it looks like it's saying OK. It's pretty funny. Water flows into tank B at a constant rate of 20.5 liters per hour. So for example, for tank B, after 1 hour, the tank will have 20.5 liters. Okay? So what is the difference between the amount of water in tank A and the amount of water in tank B at time t equals K? So this is the part where I don't know how you would figure this out, but I'm just going to give you the answer and you do what you want with it. How's that? So what you have to do to solve this is to say, when does tank A equal 20.5? When will those two be the same? Okay, so we know that A of t is this. The question is, when is that going to be equal to 20.5? Okay, so you're going to use your calculator. You're going to subtract 20.5 on each side, and you will get this. This is like television magic, right? Okay, so you're going to go to your y equals. You're going to put this into your y equals, and you're going to see where is it crossing the x-axis, and you will see that it does. You're going to do your second calc 0 function, and you're going to see t equals 0.89204. Now you might be saying, but wait, how do I know that it's that solution? Maybe it's a different solution where it's hitting the x-axis. Well, if you look at the graph, K is going to be smaller. So let me just write this down. So K is going to be smaller than the other point of intersection, which is 2.416. So the only value where it hit the x-axis that's smaller than 2.416 would be this one. Okay? So now we need to figure out how much water was in the tank for A, how much was in the water for tank B, and what is the difference in those, okay? So that part's not going to be so difficult. It was the part that I just did that I personally think is pretty crazy. But let me give you some point values in the meantime. So if you had set this thing equal to 20.5, you got 1 point. And that was it for that. Now let me give you the rest of the problem. I'm going to get rid of this. So the bad thing about this question is that if you can't do one part, you can't do the next part, and that's what really stings about this. Okay, so I'm just going to write down that we found that K equals 0.89204. Okay, so we want to know how much water went into tank A and tank B. Okay, so we'll do A first. Doesn't really matter what order I do it. So it's going from 0 to K, which is 0.89204, and you are allowed to write K up there as long as you have acknowledged what K is. Of A of T dt. You're going to use your calculator, and you are going to get 7.6876. Okay, then you can do the same thing for B of T. You're going to run into a little bit of trouble. So this is also going to go from 0 to K of B of T dt. Now, you can't put that into your calculator right now because you don't have a function. But alas, you do have a function, because you're told that between 0 and K, every hour, 20.5 liters is going in. So 20.5 is your function. Okay, so it would be 20.5 dt. You're going to use your calculator, and you're going to get this. 28682. Yep. Okay, and so let me give you some point values. So if you did both of these integrals, that was only worth 1 lousy point. Okay, and then the final part to this was you had to take, you had to subtract them. So you had to do, the question was, what's the difference between the amounts? So you're going to do 18.28682 minus 7.6876, and you will get 10.59922, and that was worth 1 point. Okay, we're on part C now, and it's talking about area. So you want the area of the region, so that's going to be the integral, and then we're going to do the top minus the bottom. Right, this is how we would normally do it, dx. Except that we have a problem because it's going from K to 2.416, and they want to know how much water is in the tank at 2.416. So it seems like there's a lot of stuff going on here. Okay, so the area we're being told is 14.47. Okay, and that's when it goes from K, and we know what K is, we already figured that out. I'll just put it in there. So that was the 0.892 number. Except they're asking how much water is in the tank, which is a completely different problem. I don't know why they're putting these two together. So if you want to know how much water is in the tank in tank B, that means that you're going to say, go from 0 to 2.416 of B of T dt. Okay, and normally we would have to add some value of what we started with, but we started with 0, so we do not have to worry about that. Okay, so the question is, what do these two things have to do with anything? So here's the problem. You can't do that 20.5 thing here and just plug it in for B of T, because that didn't start until K, and this is starting from 0. So we're going to have to break this up into two integrals, and we're going to do it like this. We're going to go from 0 to 0.892, that was the K, of B of T dt. And then to that, we're going to add the integral from K to the 2.416 of B of T dt. Okay, so we already did this part previously. In part B. And so we know that this first box over here is going to be, let me put in another color, 18.2868. We got that in part B. So this is another issue. So if you're going to do part A, you can't do part B. If you can't do part B, you can't do part C. So the whole thing's a total wash. It's completely unfair, in my opinion. Okay, so the only thing that we need to do is to find this thing. Okay? So how are we going to find that thing? All right, I'm going to go to the next screen and then I'll come back. Okay, something that we haven't used yet is this area thing, which was this. Right, it's the top minus the bottom dt. Now they told you that it was equal to this. Okay, so I'm going to break this into two separate integrals. Now, of course, it may seem like, oh, look, she can do it in the amount of time they gave, but keep in mind, I had a lot of time to think about this. And I also did have a cheat sheet, I have to admit. This was a hard question. Okay, so all I did was break it up into two separate things, okay? So now, on my calculator, I can definitely do this thing, right? Because I know what A of t is, and I have a calculator. And when I do that, I get this. Okay, and I still cannot do anything with, maybe I'll write it up here, make some, be a little neater. Okay, so I still couldn't do anything with the second interval. But at least I did the first one. Okay, so this is what we're trying to solve. Okay, if I, okay, so I have all that. Okay, if I subtract this 14.470 and I bring it to the other side, I will do this 44.497 minus the 14.470, and I'm going to get 30.027 minus this. Okay, why am I doing that? Because I want this to be brought over, oh, so annoying. I want this to be brought over to the other side so that that's positive. So I'm going to get this. Oops, I forgot my B of t. Okay, I'm going to erase all this other mess so you can just look at what happened here. I just found that the integral going from 0.892 to 2.416 of b of t is this. I'm going to go back to my previous screen. Isn't that exactly what I was supposed to be finding here? The integral from 0.892 to 2.416 of the integral of b of t? So we found that it's 30.027. So this is 30.027. Okay, and so if I add those two together, I will get this. And that was the answer. This is how much water was in the tank at t equals 2.416. Okay, so what were the point values here? If you got the answer, that was worth 1 point. And if at some point in this entire process you did, of all the things for them to pick, if you wrote an integral like this, if you just did that, you got 1 point. I'm sure you would have quit this a long time ago. I'm already at 15 minutes and I still have a part D to do. Okay, and finally, this is part D, and thank God this problem's over. I'm sure Josh and Terrell have already shut this video off. I really can't blame you. Okay, here's the information that we have. The rate of water going into B is being called W of T. And they want to know if you do W of T minus A of T, is the difference, will that be increasing or decreasing at T equals 3.5? So how do you find out about increasing or decreasing? You take the derivative. So we're going to do W prime of 3.5. And so you're going to use your calculator because we know what W of T is. They gave it to us. That was the 21, it's this thing, W of T is this. They gave it to you. Okay, so you're going to want the derivative of that, and you're going to just do that in your calculator. Okay, I'm sorry. You're going to use your calculator, but you're not going to have to find the derivative because this is the rate of water going in and out. So that already is the derivative. So you just have to put 3 point. No, what am I talking about? I should have stuck with my first thing I said. You're going to need W prime, okay? Because you want to know, is this thing W of T increasing or decreasing? So you need the derivative. Okay, so you're going to put it into your calculator, and so you're going to use the n deriv. Remember that one? That's, I think, Math 8. And you're going to put in the function. You're going to declare your variable as x, and you have to do it at 3.5. And when you work that all out, let me make this nice and neat. W prime of 3.5, you should get this. Okay, and then you have to figure out what's happening with A. So A, we have that function as well. So you're going to use your calculator, and A prime of 3.5 will give you this. Okay, so they're asking you to do this piece minus this piece, okay? So it's minus a negative, so it becomes positive. And you should get a negative 1.14298 if you keep going. Okay, getting this thing, that was worth 1 lousy point. And then you needed to say that the difference is decreasing. And that's because the derivative is a negative number. So if the derivative is negative, it's decreasing. And for all that extra work, for saying this statement, you got 1 more point. But thankfully, this problem's now over at 18 minutes.